Sorry with how much I'm going to be clearing my throat today. Hopefully it'll get better as I talk. So we're going to finish 5.1 today. It is 5.1, right? Yeah, we're going to finish 5.1. We've been talking about quadratic functions, and we talked about vertex form. We talked about standard form, which is the same thing as vertex form. We talked about a lot of things related to quadratics. Okay, so remember, this is what we were talking about yesterday. So, most parabolas are not even functions. Remember, even functions means it's symmetrical about the y-axis, symmetrical about the pen. And you can see that it's not symmetric about the pen. But there is what's called an axis of symmetry that it's symmetric about. All right? We talked about the x-intercept, we talked about the vertex, and we mentioned that the vertex in the axis of symmetry is always smack dab between the zeros. So if we use the quadratic formula to find the zeros, we can use a modified version to find the axis of symmetry. It's going to be negative b over 2a. All right? And so we're sort of going to be using that as we move on to solve some problems. Let's all get passed and call it good. I expect every single one of you to pass, so I agree. Why don't you guys just all get 100% on all the remaining quizzes and exams, and I'll be a happy camper. So we're going to talk a little bit about maximums and minimums, and then how to find them. I am sorry to say we are going to be skipping talking about domain and range of these. All right, so if you love domain and range with all your heart, we're skipping those problems in the homework. Okay, so you're right about that, Lane. It is easier said than done. So let's talk about maximums and minimums. So if you have a normal parabola, right? Most parabolas, that's not true, but our standard parabolas open up, just like this. So these have no maximums. There's no biggest, right? This parabola can get bigger and bigger and bigger and bigger and bigger and bigger, as big as it wants. But these parabolas do have minimums. Okay? Right? So if a is greater than 0, there is a minimum. So this is our normal parabolas. Okay? And remember A, oops, that's not the sheet I meant to show you. Remember A, all right, if we have vertex form, this is what vertex form looks like. And if that A is positive, it'll have a minimum. General form is in this form, it's the same A. If A is positive, we're going to have a minimum, and it's going to open up. All right? So, conversely, right, can have some other parabola upside down, right? If A is negative, we have this situation, and there is a max. All right, so if A is positive, it opens upward. If A is negative, we can think about that as a vertical reflection in some sense, although it's not exactly a reflection about the x-axis. If A is negative, then there's going to be a maximum. All right, and that'll be a couple homework problems, but it's relatively straightforward once you know what the A means. So let's do some problems, and these are the problems. These are the problems that are going to be tough. Okay, when you're doing the homework, you might struggle with some of it, but these example problems, these application problems, are going to probably be the biggest struggle of this section. And this is going to be confusing. Okay, so as always, please just say something if I lose you at a point. If you're wondering why something happened, where something happened, what's going on, just bring my attention to what is confusing you, or where you get lost. So example 4, we've got a mathematical farmer on our hands. We've got the stereotypical, the most common garbage math example problem in existence almost. These but anyway, it's a silly problem. But maybe it's a good problem. Who knows? I'm not a farmer. I don't know how much math farmers use. So a farmer has 80 feet of fencing, and he or she wants to enclose a rectangular space. That's not how you spell that word. All right, that O is migrating. A rectangular space, don't worry about that, against a wall. All right, so, say there's some wall. And then he wants to fence 3 sides to get a rectangular enclosure. Okay? So I don't know what it's going to look like. I don't know the dimensions. But the area of that rectangular enclosure, we're going to call some A. Now I'm going to ask you some questions about that. In part A, we'll talk about this. All right, so find a formula for the area A of its length L. So, right, your answer should look like A of L equals blah, blah, blah. All right, so we know that the area is the length times the width. So it's easy to say A is equal to LW. But it's more important if we can find the area function as a function of only one variable, we can do a lot more with that. And you might say, well, but there's 2 variables, Jason. How do we get a function of one variable? And the answer is substitution. If you remember solving systems of equations, substituting something out, we're going to be doing a little bit about that. So first off, we need to say what L and W are. What is the length? What is the width? And it doesn't matter which one you choose. It really doesn't matter which one you choose. There will be kind of 2 different answers. But I think length is usually the longer one and width is the shorter one, but we don't know which one's longer. So choose whichever one. Let's say this is L, this is W, so this also has to be W then. So, what do we know? We know that the area is equal to the length times the width, right? But that's 2 variables. We do not want to worry about functions of 2 variables right now. We want functions of 1 variable. If you have functions of 2 variables, we'll talk a little bit more about that in calculus, but usually in Calc 3. So that's a bit in the future, okay? For anyone who's going on to Calc 3, you got a little bit of time before we're dealing with functions of 2 variables. So we need to get rid of one of these variables, right? Can get rid of one with my good friend substitution. Calc 3 is actually not that bad. A lot of people think like Calc 1 is bad and then Calc 2 gets worse and then Calc 3 gets worse. But it's not really, it doesn't really work like that. It's more, it's less of just harder and harder material and more like, here's one element of calculus. Here's another element of calculus. Here's another element of calculus. So I don't think Calc 3 is that bad. Calc 2 is usually the worst, actually. And then Calc 3 is just like, oh, do it again, but with more variables. So, if anyone's taking that, you got something to look forward to. So, to substitute, what else do we know? Right? So someone tell me in chat, what piece of information in this problem have we not used yet? There's a couple different answers you can give. But someone tell me something else that we know that we have not used yet in this problem. Exactly, Monet. We haven't used the fact that we have 80 feet of fencing. Yeah, very good, Delaney. So we have 80 feet of fencing. This is what we're going to use somehow in the substitution. So later on in part B, I haven't mentioned it yet, but we are trying to maximize this area. So we want to use all the fencing. Technically, we don't need to use all the fencing, but if we're trying to make it the biggest possible, yeah, we're going to use all the fencing that we can. So we want this plus this plus this, right? These are our 3 sections of fence. We want that to use up the entire fencing area, or length. So we're going to write that with math, that we want all of this to use up all 80 feet of fencing. So W plus L plus another W has to add up to 80 feet. And this is what we're going to use for substitution. So this right here is important. Area is the length times the width. We'll utilize this in some sort of substitution method to get rid of one of these variables. Just like when you were solving systems of equations, if anyone remembers doing that. All right, so let's move on to actually solve it. My wallet is causing so many problems today. All right, so, we have area is equal to length times width, and the other thing we got was 2W plus L was 80. So you can choose one of these variables to solve for to get rid of it. And specifically, the problem wanted you to write it, right? Problem asked for A of L. So we want to get rid of W. If we get rid of the W, we'll have solved the problem. So to get rid of the W, we need to solve for it so that we can substitute it out. So we subtract an L from both sides. We get 2W equals 80 minus L. Then we divide both sides by 2. W is going to be, this divided by 2 is 40, minus, I'm going to write it as 1/2 L. But you could also write it as L divided by 2. So we substitute the W out. Right? Area is the length times the width. But notice the width is just 40 minus 1/2 L. If W is equal to this, they are the same thing. And we can just replace the W with what it's equal to. So area as a function of L, right? This is just function notation. This means the same as this. These two left-hand sides are the exact same thing. This is just how we write it as a function. But realistically, they mean basically the same thing. Length times the width. Well, what is the width? The width is 40 minus 1/2 L. We have solved the problem. If you distributed this, that would be good. But we don't have to. If you're ever curious on exams or tests whether I want you to write something in a different way, you can always send me a message over it on Discord, all right? And say, hey, for problem 2, did you want me to distribute? And then I can say yes or no, or maybe I'll ask what you have or where you're at, sort of a deal, and answer your questions that way, all right? Which is one advantage to us doing quizzes and exams synchronously at the same time, is that I can make sure that I'm there and available to answer any questions that you have, which I think is important. Okay, so that's part A. And so for all of these problems, when you get to these on the homework, you're going to sort of approach these problems the same way that we're doing it today. You have some function, some formula with 2 variables, and a lot of times you need to get rid of one of them. So you use substitution using some piece of information from the problem. That's going to be the group of problems right here at the end of the section, right, for the homework. So number 67, for example, is going to be kind of similar to what we're doing in this problem. We haven't done part B yet, right? Rectangular corral, split into 2 pens of the same size, greatest possible area. You're going to set up something with an area formula and then use this 300 feet to get rid of one of the variables. All right, but anyway, we'll finish the problem. Part B. What dimensions maximize the area? So let's tie things together, right? When we started talking today, we said, okay, if we have parabolas, if we have quadratics, if we have a positive coefficient of the squared value, it opens up and we have a minimum. if we have a negative coefficient to that squared value, it opens downwards and there's a max. So this problem is saying, how do we maximize the area? Well, let's do a gut check and see, is this area formula even a quadratic that can be maximized? All right, so let's look at our area formula, right? A of L, let's distribute that now, is 40L minus 1/2 L squared. Or if we wanted to write it in general form, and again, remember general form is this. If we wanted to write it in general form, we'll switch the order. Negative 1/2 L squared plus 40L, and then plus 0. So notice this is a quadratic function. There's no constant term, but it's a quadratic function. And this right here is our A value, and it's negative. So that means the parabola opens down, and there will be a maximum at the top. It's really hard to make a parabola with your hand. I would have to like cut off my wrist. Otherwise it's, well, let's not do that. So, oh, you wanted to see my cat. He is sleeping, so you can't see him, but there's also, you're seeing a little part of him, a little hair. So, we want to find out what maximizes this area. Where is the maximum of a parabola? Let's go back to talking. Remember yesterday when we talked about a parabola, the minimum of the parabola occurs at the vertex. If we have an upward parabola, the minimum is going to be at the vertex. If we have a downward parabola, the maximum is going to be at the vertex too. Yeah. So the max or the min always occurs at the vertex. So this problem sounds fancy, but all we're asking you to do is find the vertex and then answer it in a way that makes sense. And I've been having the weirdest burps. So we need to find the vertex. So again, go back to this picture. Where is the vertex? The vertex occurs on the axis of symmetry. And the axis of symmetry is always right between the two zeros. And we said, okay, we can find that with this little formula. This is where the axis of symmetry is, negative b over 2a. Or you can complete the square if you really want to be a superstar. All right. So, vertex is on the axis of symmetry, which is the line x equals negative b over 2a. And this is something that you can memorize if you want, but remember where it comes from. This is the midpoint of the two zeros, right? And the zeros are found from the quadratic formula, right? And this is like half of the quadratic formula. Remember, the quadratic formula is negative b plus or minus the square root of blah, 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 all over 2a. So it's just a quadratic formula without the square root. Okay. So we need to find that. So we don't have x's here, actually. We have l's. So L is going to be negative b. B is the coefficient of the linear term. The coefficient of the variable with no exponent. Technically has an exponent of 1, but that's splitting hairs. I can't split the cat hair. I already threw it on the ground for the vacuum. So negative b is negative 40 divided by 2 times a, which is negative 1/2. I'm starting to write a little small. I'll try to write bigger. All right. So we're going to get L equals, what is this, negative 40 over negative 1? 2 times negative 1/2 is just negative 1. Oh, that's just 40. So are we done? Almost done. But, right, what was the question asking? The question was asking, what dimensions maximize the area? Now, I'm no English teacher, but I would like to point out this thing called an S. It's a letter of the English alphabet, also used in many other alphabets as well. And it means plural. It means multiple dimensions, right? We have a picture. Not over here, we don't. We got a picture somewhere. This is the situation. We got the wall. We found that the length has to be 40, but dimensions, we need to tell them what the width is going to be as well. All right. So one of the dimensions is going to be 40 because the maximum occurs at the vertex. The vertex is on the axis of symmetry. We found out that that happens when the length is 40. Well, think about it this way, Delaney. It may give you multiple headaches, but the advantage to multiple headaches is that in order to have multiple headaches, you have to get one and then feel better so you can get another one. The worst case scenario would only be to have a single headache that just never goes away, right? So, silver linings. All right, so need to find W. All right, so let's see. We found that L is 40. How do we find W? Watch this. We found that W, that was a gross sound effect. W is 40 minus 1/2 L. So we're going to use this to do it. So let's take this formula all the way down here. Right? W is equal to 40 minus 1/2 L. We already found that. We already did that. That was in part A. So if L is 40, we find out what W has to be. It's going to be 40 minus 1/2 times L, which is 40. Unfortunate that these two are the same numbers. It kind of looks confusing. So it's 1/2 of 40 is 20. 40 minus 20 is 20. Okay? So we found out that the length has to be 40 and the width has to be 20. But we're not going to have a 40-inch enclosure. Right? What are our units here? The fence was 80 feet. Right? So it's going to be 40 by 20. 40 feet by 20 feet is our answer. Or if instead of writing your answer like that, you wanted to use a picture, you could use a picture like this. This is 40 feet. These are 20 feet. And like there's a cow in the middle. I don't remember what cows look like. That's a big cow. All right, that's how you express your answer. Express your answer. Looks like the cow has like salami on him or pepperoni. All right, so that took about 20-something minutes. Time to do another one. Any questions so far? The next one's even better. The next one's really interesting. The next one is something that realistically could happen. For all you aspiring business owners out there. That poor cow. Yeah. Why do you think he's mooing so sonorously? That's a word, right? Sonorously? I don't know how to say it. Giving out or capable of giving out a sound. All right, that's not the word I meant. That's not the word I wanted. Looks like a nice steak. Ooh. Okay. All right. So let's do another problem. Example 5. Okay. So we have a newspaper. those there's not many of those left. Newspaper has 84,000 subscribers. All right. At a quarterly charge, so that means every 3 months, 4 times a year, of $30. So this newspaper is losing money. It's losing money because people don't really read a lot of newspapers anymore. So what they did is they there's a period right here. What they did is they worked with a market research firm, some kind of consultant, to get some information about the situation. Specifically, what their consultant told them is that market research suggests that if the price is raised by $30, so if they double their subscription cost, if the price is raised by $30, they would only lose 5,000 subscribers. Right? And this is essentially a situation that's very, very common in any business ever, right? Is if you have you have customers, right? And if you raise the price, obviously, then you make more money per unit, whatever you're producing, newspaper subscriptions or any other sort of object. But of course, the more you raise the price, the fewer people are going to buy it. So in deciding how much you want to charge, you're trying to optimize how much money you make per unit, but also how many people are buying your product. Okay, and a lot of times, if through simple models, that can be modeled through a quadratic equation, as we are going to talk about. And you want to find the maximum profit that you can get. Okay, and so math is really a great way to utilize this and use this information to maximize your money. Fun side note that I'm not going to talk about for too long is that one of the research that I did to get my master's degree really did focus on optimizing situations like this and the business aspect of things, and trying to save the most money. And yeah, it's kind of a funny situation that they are doubling the price and would only lose 5,000 of their 84,000 subscribers. But a lot of subscription services kind of work like that, where they kind of do like sneaky changes and people just are subbing and they're not canceling their subs, and you can get away with a lot like that. Anyway, this is what we have here. So here we go. Part A. Write an equation relating cost and subscribers. This is going to be the hardest part. And in these examples in class, I'm really trying to break down the steps with A, B's, and C's. But again, on your homework assignment, a lot of times you're really just asked a big question. So we recently did something like 67. Now we're doing something kind of like 71 or I just saw it. Where did it go? Yes, something like 71. Where it all kind of asks it together. You're going to have to break it down into steps like we're doing in these notes. All right. Cost and subscribers. So notice that they have 84,000 right now with a cost of 30. They would lose 5,000 subscribers if the cost increased by 30 to 60. This is a linear equation. Okay? This is a line. And hopefully you remember how to find the equation of a line. Right? This is a line. So, right? If a cost of 30 means that we have 84,000 subscribers, right? This is our current situation. Cost, I'll abbreviate subs. And we have another point on this line as well, right? If the price is raised by 30, so that means it becomes $60, they would lose 5,000 subscribers. So we'd have 79,000. That's one way to find the equation of a line. We have 2 points. We can find the slope and use slope-intercept form or point-slope form. A lot of different ways to find the equation of a line. The important thing is that once we get our 2 points, it becomes a little simpler. So let's find the slope. Remember that the slope m is the rise over run. So it's going to be the change in y. This goes down 5,000, so we'd have negative 5,000. Divided by the change in x, this goes up 30, so we'd have plus 30. Or if you want to use a formula, it's going to be 79,000 minus 84,000 divided by 60 minus 30. Usually the right minus the left, which becomes negative 5,000 divided by 30. One of the zeros is going to cancel. Negative 500 over 3. What is that? About 160, negative 167.7, I think. Yeah, approximately, well, say negative 167.6 repeating. Or 166, goodness. Whew. Okay. So once we found the slope, we have a slope, we have a point, we can use point-slope form or any other formula you want. Hopefully you remember these things, and if not, this is a good refresher. Point-slope says y minus y1 equals m times x minus x1. So y1 is that 84,000. Equals m, which is negative, let's write it as a fraction, negative 500 thirds. You could write it either form, times x minus x1, which is 30. Okay, so this is one equation relating the cost of the subscription to the number of subscribers. We can write this another way, right? Add 84,000 on both sides. You get negative 500 over 3 times x minus 30 plus 84,000. And if most people like slope-intercept form, so if you want to use slope-intercept form, you're going to have to distribute that. So if you distribute this coefficient, you get negative 500 over 3 times x plus, when you multiply this out, I believe you get 5,000. Plus 84,000. There are quicker ways of doing this, but this one's a little bit straightforward. More straightforward anyway than the other stuff. So if x is the cost and y is the subscribers, this is an equation that relates the number of subscribers to cost. And again, this is a simplification. Whenever you do this sort of market research, it really only works for a small domain, right? For example, this says that, if we literally had a free newspaper, if the cost was 0, only 89,000 people would subscribe. Maybe that's true. But you could get more ridiculous with this, right? If the cost was like negative 5,000, if you're literally paying people to take your newspaper, domain is important whenever you're thinking about this. For what values of the input does this equation make sense? Whenever you do this sort of market research, it's always a very local situation. Local in mathematical terms means like nearby the points that you're given. So we can't extrapolate very far. We can't go very far away. Like we can't have x be very big or very small and have this still make sense, but it's still useful. All right. That's another side rand. And that's just part A. Okay, so we have an equation relating the cost of the newspaper subscription with the number of subscribers. So it's at this point probably where people are maybe either feeling very overwhelmed or just have checked out. So it's a great time for an attendance question. So someone in chat, give me a good attendance question for today so I don't have to be creative. If you're sleeping, now's the time to wake up before part B. I had a good idea for an attendance question, but I forgot it. Oh, yes. So for today's attendance question, a type of facial hair. So the mustache, beard, mutton chops, goatee. Biggest pet peeve is a good one too. But yeah, we'll do type of facial hair today. So for your attendance, extra credit points today, Discord me some type of facial hair. Bonus points. That's not true. I can't joke about bonus points. But I'll be happy if you give me something weird. But you don't have to. Then we're going to go on to part B. Okay. I'm going to need to keep this. Part B is going to be easier than part A, I think, if I remember correctly. So part B. Write an equation relating revenue and cost. So the revenue is just going to be profit minus cost. I don't think this is what I'm I don't think this is what I was trying to ask, though. Maybe we should change it to revenue and number of subscribers. Okay. So, right, so how much we make is just going to be how many subscribers we have and how much they're paying us for their subscription. Right? Here, we should, while we're doing this, we should rewrite this formula. Let's call subs S and the cost C, just to make things a little bit more straightforward. So we can remember, we don't have to remember what Y and X means. S for subs, C for cost. All right. So the revenue really is just the cost times the number of subscribers. Right? If I've got 5 people, this is your quarterly revenue. If I have 5 people and they're giving me $30 for this newspaper, I'm going to have 5 times 30, $150. Okay. And that's all part B. Part A was much longer. But notice what we did. Now we have a situation just like in the previous example, right? This is a function of 2 variables, the cost and the number of subscribers. But look what we just did in part A. We related the number of subscribers to the cost. We can use substitution now to turn the S into something with C's and get a quadratic equation. Okay. So again, this is an equation relating the revenue to the cost and the subscribers. Oh, dang it. I now remember what I wanted to ask and why I wanted to ask it. And cost, C, only. So we want to get rid of the S. It was indeed correct over here. So we're going to substitute, just like we did before, right? substitute out the s. So then we'll have a function of only one variable. So s, we just said, was equal to all this. So we substituted out and replaced the s with all that. So the revenue is a function of C, and it's equal to the cost times the number of subscribers, which we just said was negative 500 over 3 times C plus 89,000. And now we have, what do we have? We have a function of one variable that if we distributed, right? If we distributed, what kind of function would that be? If we distributed that C, we have a quadratic function. Wow! A quadratic function. That's what we're going to use in part C. Okay? So in part C, what should the cost be? To maximize revenue. So again, right, this is a quadratic function. It's a quadratic function with a is negative. So it opens downwards. The maximum is at the vertex. Just like before, we need to find the vertex. And remember, the vertex, just like before, is on the axis of symmetry. So now we're using 5.1. Remember, the axis of symmetry is negative b over 2a, and our variable is here c, so c is negative b over 2a. That's where the axis of symmetry is. That's where that cost is going to be. And remember that this formula is just the quadratic formula without the square root. So, this is going to be ugly. Negative b is going to be negative 89,000 divided by 2 times a, which is negative 500 thirds. Let's type that into a calculator. You could simplify it by hand if you wanted to, but we'll type it in. If you type that into a calculator, you get negative 89,000 divided by 2 times negative 500 divided by 3. You're going to get this is something interesting. You're going to get 267. $267 is what you should be charging these people as a newspaper company to maximize your revenue. It's going to halve your number of subscribers. If you actually did this, you would only have half as many subscribers, but they love your newspaper. And they're going to pay out the nose for this newspaper. Yeah. This is some questionable market research, I think. Really, this number this number spawns by the fact that doubling your quarterly charge only reduces your subs by 5,000, which is crazy. I remember last semester, I remember this example now. I just changed this. Yeah, I'm going to change up my notes so I don't do this again, because this is crazy. This is an expensive newspaper. Oh, man. But that's the problem anyway, and that's how it works. So you're really going to have to mimic these two problems when you do your homework. It's kind of funny, though. Kind of funny indeed. Essentially what you're going to get into as well, if anybody's interested in like the business aspect of anything, is you get into stuff called marginal cost. And marginal cost in this situation talks about like how many subscribers you lose for like a unit of cost increase, or vice versa, which is really, really closely related to derivatives and partial derivatives if you get into calculus. In the fall, I'll be teaching business calculus. I think I'll have some of you in that class. If anyone's a business major, business calculus will be in the fall, which I'm really looking forward to. It's one of my passions, so it should be fun to talk about. This is some really interesting stuff that you can get into with math and business and optimizing profits and using math for decision making and stuff. It's cool. But anyway, that's the problem. So I hope everyone's ready to exhale, because those were we did 2 problems in 46 minutes. All right. And they're good problems. They're juicy, spicy problems. But we're going to go on to some simpler problems. Let's finish the section with 2 more problems. Hopefully we can finish it in time. We're going to talk about intercepts. So we've already talked a little bit about intercepts before. Remember, let's go back to our picture. Oh, I remember exactly what we said about using those words, Lexi. I'm just trying to get a rise out of you guys. All right. It's a good problem. Those are problems you can sink your teeth into. So remember, x-intercepts are the zeros, and that's where we can use a quadratic formula. Y-intercept is when x equals 0, and those are usually a lot easier. We're going to be talking about intercepts right now. Okay, so easy problem right here. Easy problem. Well, not easy, but not as hard as the last 2. Find the x and y-intercepts of f of x equals 3x squared plus 5x minus 2. All right, and this isn't as bad. It's not great, but it's not as bad. And all of you have done this before. Now, whether you remember how to do it, who knows? Okay, but remember, right, the x-intercept is when y equals 0. The x-intercept is when I'm seeing some equal signs right there. When y is 0, what do we get? We get 0 is equal to 3x squared plus 5x minus 2. And good golly, polywogs, is a quadratic equation. How do we solve quadratic equations? We can factor, we can complete the square, we can use a quadratic formula. Whoa! How fun. Oh, this is a nice problem. This one does factor. Right? We could use the AC method. What multiplies to -6? That adds to 5. 6 and -1. You could factor it that way. But a lot of people really like the quadratic formula, so I'm going to try to remind you how the quadratic formula works. If you wanted to use the quadratic formula, you'd say x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And you just plug that in. So b is 5, so you get -5, plus or minus the square root of b squared. 5 squared is 25, minus 4 times a, which is 3, times c, which is -2. Careful when you have negatives right here. These negatives cancel. A negative times a negative is a positive. All over 2 times a, which is 3. All right. So that's going to give us, what is that going to give us when we simplify? -5 plus or minus 49 over 6. And you just keep simplifying like this. -5 plus or minus 7 over 6. So you get -5 minus 7 over 6. And -5 plus 7 over 6. -12 over 6 is -2. 2 over 6 is 1/3. So these are your x-intercepts. And we were also asked to find the y-intercept, right? Remember our function was f of x equals 3x squared plus 5x minus 2. Y-intercept is much nicer, right? The y-intercept is when x equals 0, or when x equals 0. So you just plug in 0 here. Yeah, I agree, Lexi. I love factoring. I would factor whenever possible. But a lot of people like using the quadratic formula all the time. And so I feel like since I never do the quadratic formula, it's a little harder to see how to use it. And if they're going to use it anyway, I want to make sure I use it every once in a while so they can see it. But yeah, I agree. I would use the AC method for sure here myself. So when x equals 0, what do we have? You get y equals 3 times 0 squared plus 5 times 0 minus 2. Well, that's just 0. That's just 0. Y equals negative 2. This one's much nicer. Y-intercept is always much quicker to find. Well, not always, actually. Not if it's in factored form. Okay. So those are the x and y intercepts. Not as bad as the previous example, right? So one last example to tie it all together like a giant bow in my hair, a giant mustache. Every hair in this mustache is like a piece of this section. I don't know, this is getting weird. Let's move on to the last problem. Example 7. Example 7's not as nice as 6, but not as bad as 5 was either. All right. Let's say a math textbook is thrown up, not like puking, but is thrown up into the air at a speed of, let's say, 5 feet per second. The height after t seconds is given by h of t is equal to negative 16 t squared plus 5t plus 5. We're going to answer some stuff. When does the book reach its max height? Fun fact, by the way, I have once jumped in a pool in winter. It was a California winter, but in the winter with a math textbook. The secret was to keep the textbook clutched really tightly so the water couldn't soak in, and throw it out immediately afterwards. If anyone ever wants to jump into a pool with a math textbook, you can ask me. I have experience. Okay? We got to finish this section in the next 8 minutes. All right? So, max height. Quadratic function. When does it reach the max height? Maximum is at the vertex. Okay? Max is at the vertex. So just like before, we need to find the equation for the axis of symmetry so we can find the vertex. We do this just like we did it before, right? It's going to be when our input variable, which is t, is negative b over 2a. We've been doing this a lot now. Negative b is negative 5 over 2 times a, which is negative 16. Simplify that out, that's going to be 5 over 32. What is 5 over 32 as a decimal? 0.15625 seconds. So it doesn't take long. We didn't throw this math book very hard. It was probably a big book. Only after like 1/6 of a second does it reach its max height. So our answer is going to be after 0.15625 seconds. So question B is going to follow as well. Question B asks, what is that max height? All right. How high does it get? Again, max is at the vertex. So what we did in part A is we found the input coordinate for the vertex. Now we need to find the output, right? So find h at that time from A. All right. We can talk more about this tomorrow, but I want to make sure that I get through it today before your quiz. So we just plug in our answer from A, which was 530 seconds. H of 530 seconds is going to be negative 16 times 530 seconds squared plus 5 times 5 over 30 second plus 5. We just plug that into a calculator. Okay. If you do that, you get 5 points. Goodness, it really does not travel very far. 5.39 feet into the air. We're really not throwing this book very hard. Okay. Last thing we do before the quiz. Part C is somewhere. When does it land? So let's go all the way back to the beginning of the section. Well, maximum is at the vertex. Well, if this is the height, it lands when the height is 0. Ah. Yeah, the throw started at 5 feet in the air. We give it a little baby throw. It only gained 2/5 of a foot, and it started falling. It lands when h is 0. So when 0 equals negative 16 t squared plus 5t plus 5. Whoa, that's a quadratic equation. Whoa, we can use a quadratic formula again or factor it. This one's not going to factor though. All right, so use the quadratic formula. And again, we don't have much time, so I'm just going to speed through this. T equals negative b plus or minus the square root b squared minus 4 times ac all over 2a. So you just plug that in. You get negative 5 plus or minus square root of 25 minus 4 times negative 16 times 5 all over 2 times negative 16. Which is negative 5 plus or minus the square root. This simplifies to, what is that radicand? 25 plus 4 times 16 plus 5, 345. All over negative 32. Let's approximate our answers. Well, if one of these answers is negative 5 plus the square root of 345 divided by negative 32, that's going to be negative 0.42 seconds. The other answer is going to be positive 0.74 seconds. So you're not going to give me 2 answers for this. If you give me 2 answers for this, I'm going to be very grumpy. When does it land? It's going to land, we're not going to worry about negative time right now. After 0.74 seconds. So about 3/4 of a second for it to land. That's how you do these sorts of problems, okay? These application problems are going to be the trickiest. I can almost guarantee there's going to be an application problem on your quiz on Tuesday. Okay? Good, Lexi. All right, it's quiz time. Go ahead and take your quiz. Feel free to ask questions tomorrow. tonight, over the weekend, 3 o'clock in the morning. I'm not going to answer your questions at 3 o'clock in the morning, but you can send them, and I'll answer them when I have a free moment. Again, there's not that many of you, so I'm willing to answer questions. Good luck on your quiz.